Good afternoon, everybody. I hope my audio is audible and my screen is visible. So if you have any query regarding that, you can type it in the chat window so that I will know that if any problem is there. Okay, so let me begin. Hello all, I am Gaurav Harne, Application Engineer at Engineering Technique, specialized in finite element including flow simulation, plastic ejection, etc. Today's topic, improve the performance of valve using SOLIDWORKS Flow Simulation. So today is a dedicated topic with respect to the flow industries, right? Valve industries. So today's agenda, I will take you through what is the fluid flow analysis, why SOLIDWORKS Flow Simulation, I mean how it is advantageous or what are the benefits of switching to simulation as compared to the physical testing, correct? Then improve your everyday productivity with SOLIDWORKS Flow Simulation. Then we will check few case studies, correct? Of valves and how we can make use of all the things which are available in the software and what are the results that we get and how it will again affect our productivity. Then we will move on with few of the problems like cavitation is one of the common problem, how that thing can be addressed from the software. And lastly, we will check how optimization can be done with respect to the valve. Market trends for simulation. The market trends have never been stronger than before for simulation. It has been proven by broad design, engineering and manufacturing industries that simulation helps launching new product to the market faster. The benefits have been proven and are multiple. Faster product development, less prototyping, more innovation, faster and informed decision on designs. Another key factor is customer satisfaction in providing not only innovative but high quality products. The bottom line is that simulation helps you to be more competitive in your market or in your expertise. Now what is fluid flow analysis? Before I jump on into the actual SOLIDWORKS flow simulation, let me give you a brief short idea what is fluid flow analysis. Correct? Now simulation of real life fluid and heat transfer problems on the computer. Correct? So we actually perform all the analysis on the computer. It converts these real life problems into equations and solves them numerically using power of computer. Now everybody is aware that 3D CAD modeling is now the world is switching, correct? The 2D CAD modeling days are now, I can say, gone, correct? Everybody is switching into 3D CAD modeling and trust me, 3D CAD model is having so much power that you can make use of it, correct? By performing simulations on your model. Correct? And engineers designing product that relate to flow of gas, liquid, heat transfer and forces on solid can greatly benefit from this technology. Correct? Now the flow may be of liquid, gas or anything. Even the heats can be transferred on your products. It can be valve, heat exchanger, anything. Correct? And how it affects your product. Correct? That is the thing what we check in the fluid flow analysis, so that great benefits the designers while they design their products. Now, as you can understand from this picture that this is a simple setup of a physical testing of the valve. Correct? Now, most of the industries that are not leveraging the advantages of FEA analysis or flow simulation, right? So they have to rely on the physical testing of their valves. Now again, it can be much more time consuming, it can be much more costly because of the setup it requires, the time investment is more. So all these things are, I can say, eradicated, or it can be removed once we make use of the simulation tools like flow simulation and so on. Now, as we know, the costs of all these physical testings are, I will not say much higher, but they are at a little bit higher side, correct? Which again eradicates, or it again reduces the profit, I can say, finally, of any organization. So any organization runs to gain more and more profit. So finally it comes down to the profit, correct? So this is just a small introduction that how physical testings and everything can be eradicated because they are time consuming and the setup is costly, and how we can rely on virtual validation, correct? Now, reducing the experimental testing and prototyping. So what you will achieve using the simulation tools is the faster lead time, correct? It is less expensive than the physical testing or prototype. Now, if you want to do the physical testing of the component, now for each and every component, a different setups are required, correct? It can be either valves, correct? Either it can be pipes, either it can be any other product. The setup is more or less little bit different. So again, if we take advantage of such virtual validation, it is less expensive than the physical testing. We can investigate more options, correct? Like what if scenarios, which is included in the software. Like if you want to do the analysis by different inputs, correct? So you can perform various what if scenarios, various scenarios where you want to change your designs, correct? Now in physical testing, you perform the test on a single design which you have manufactured, but this is not the case when you perform the virtual validation, correct? So you can investigate on any design, you can switch from one design to another design on which you want to perform the analysis, right? So advantages are many, more comprehensive results. So you after the analysis are completed, you will get a good visualization of all the results, correct? Either it can be your pressures, either it can be your velocities, either it can be your pressure drops, etc. So it will give you a good visualization of results for better understanding and to make a good informed decisions on your product. Again, requires less effort, that is manpower requirement is less as compared to the physical testing, correct? A single person, I can say, can perform all such types of analysis, correct, as compared to the physical testing. Again, these are the few advantages what you can rely on when you are converting from physical testing to virtual validation. Now the key values like are innovation. You will have increase in your innovation of your product. Performance of your products will increase, right? Because anything that you manufacture, you validate in the software itself, and then it is good to go for manufacturing. You can optimize your products, correct? If you have designed your product with more materials, I can say, right? So material can be reduced, it can be optimized, correct? So again, material saving will again help in increasing the profit of any organization, and you will have a confidence in your mind that whatever you have designed, after it has been validated, will not fail in the actual or physical world. And costs, yes, from starting I was talking about the profit, the company stands on the profits, right? So the costs will be reduced, the time to market will be reduced of any new product development, correct? The product development cycle, I know, is a bit lengthy, correct? So in that, if you include physical testing and all those things, it will again take time. But if you combine your 3D modeling and the virtual validation together, that is physical testing together inside the software, again the time to market to launch a new product will be reduced, correct? Failure rates, the failures of your products will be reduced. If after the physical testing you come to know that the part is failing, it will again increase the cost, increase the time to market, and the physical testing setup you will have to do it again for different component or say different design, right? So all these things can be reduced or decreased. And the risk factor, whenever we are into new product development, there is a risk in my mind. So all these things can be reduced. Just let me check if there are any queries. Yeah, okay. I will again. So this was a brief introduction that why we should leverage advantages of virtual testing, right, as compared to the physical prototyping. I am not saying physical prototyping we should like ignore or we should eradicate it, correct? But there are more advantages of virtual testing as compared to physical prototyping. Now let me begin with one case study of a globe wall. As we know, I have tailor-made this webinar for the valves industries and how flow simulation you can make use, right, to extract the results, correct, to manufacture your valves correctly. So this is an example what I am going to show today is on a globe wall, and these are the few things like my aim is to calculate the CV, the flow coefficient, correct? Now this is a very important term while we choose any valves, correct? So, and the inputs, the inlet condition is this flow of 36 meter cube per hour from one end, the temperature is as mentioned, and outlet is at environmental condition, correct? And we know all that the valve operates at various conditions. So I will perform the analysis for various conditions, like if it is 25% open, 50, 75 or 100%, I open it full, correct? So this is my problem statement. My aim is to calculate the flow coefficient. So depending on the CV number, it will help me to decide how much inch diameter of wall should be chosen for the particular application, right? Now we know walls are very important in any industry. If I say, correct, either it can be process industry, chemical industry, correct? So selection of proper wall is very important. Now these are the various configurations that I have made inside my CAD model. So we can see there is a wall seat. In the first image it is full open, then it is 75% open, that is 3/4, then it is 50% open, and finally 25% open, correct? So these are the configurations which I will make use while performing the analysis. Now how to set up the study? As I said you in the starting of my webinar that 3D CAD model is very important, correct? So it plays very important role. It not only helps you to better visualize your product, correct, while you design, it will also help you to perform any things like analysis, flow simulation and so on your 3D CAD model. Gone are the days when only 2D models were of that importance, 2D CAD models, but nowadays 3D models are very powerful, right? So from that you can generate your 2D drawings, you can even perform such high-end analysis also. So 3D CAD models are very important, they are very powerful. Now the setting up of flow simulation is very easy, right? So from here, this is an interactive tool which is available, which will give you it will ask you all the things what all you want to do in analysis, correct? So the next step is you can customize it. Customize all the units as per the project or industry standard. Correct? Either it can be CGS, IPS, FPS, or you can create your own custom units which you are following in your organization. Correct? So the units play a very important role. You should not get confused in the units. Correct? So the first thing it takes care is about the units. Then it easily captures the project characteristics. Correct? So the first thing is either you want to perform internal analysis or external analysis. Correct? As the name suggests, internal analysis is the analysis in which the flow is occurring inside your product, inside your cavity, like an example of a wall. Correct? And external analysis, if I talk, it can include various examples like flow around the object, right? Like the flow around the solar panels. Correct? Flow around any vehicle. Correct? If you want to check the aerodynamic of any vehicle, then we perform external analysis. So pretty easy, it has divided the two things. So in case of walls, it is always internal analysis. Also, you can include heat conduction in solid if you want to check temperatures coming up in your solid, right? If you have applied the material of say plain carbon steel, so because of the flow, correct, whether your part is getting heated up, so what is the temperature it may reach, correct? Even radiation analysis can be done, correct? So these are all the things which you can provide as an input. It has an extensive library of fluids. Correct. If I talk about fluid, it includes gases, liquids, even there are few non-Newtonian fluids also, compressible and real gases too. Correct. So all the predefined fluids are inbuilt inside the SolidWorks, but if you want to create your own custom material also, you can create them. You can save it and repeatedly you can use it again and again. Same goes to the solid materials also. Again, the libraries are available for your repetitive use, correct? And you can customize the library also. Finally, once you provide all the initial conditions, like what are the thermodynamic parameters, what is the pressure, temperature, what is the velocity, and so on, then your project is set up. So I will directly go into the software and make you understand how easily we can provide all these things what I have mentioned in the software. Correct. I hope my software screen is visible to everybody. Correct. So if there are any queries, I will just let me know in the chat window, correct, which will help me to understand if there is any audio problem or so on. Okay, as I have mentioned, this is my 3D CAD model of the wall. So it is created using all the features, 3D features which are available inside the SolidWorks, correct? And let me just take the section. So I will take the section and I will show you all the internals, correct? How the cavity is made, how is the wall seat, right, etc. And if I talk about the analysis, correct, now SolidWorks Flow Simulation, you will just have to select the add-in, that is switch on this tab, and all the features which are required for your analysis will come up over here, correct? Like what are the conditions you want to provide, pressure, velocity, and so on, correct? So I will just go here and I will create a new wizard. So you can just type in here the name of your project. Even you can select the configurations. right? While modeling, I have created various configuration according to the openings. So you can select it accordingly on which configuration you want to perform the analysis. And as I have mentioned, you can select the units. Now in pressure and stress, there are few more units which are available, correct? If I talk about velocity, so all the unit system is available over here. You can make use of this. Then internal and external analysis, as I have mentioned, internal, as in this case I want to do the analysis of wall, so I will select my internal analysis and move ahead. Regarding to the fluids, right, if I expand the gases, it will show various predefined fluids available, correct, in gases. Okay. 1 second, is there right now I'm not showing presentation, I am inside the software. Correct? Okay. And similar goes to the liquids. So these are the various liquids which are available. Water is available, right? As in this case, I want to select water as the fluid. And once you select your fluid, I will just go next. You can even define the wall conditions. If there is heat transfer occurring between, right? So you can specify the heat transfer rate, also the roughness values, correct? If it is adiabatic wall, right? And finally, we define the initial conditions. And once done, we'll just say finish. And the wizard is created over here. Now, the first and the foremost thing what we do once we create the wizard is to check the fluid, correct? We check the fluid volume. Yes. So it beautifully shows the cavity or where the fluid is flowing, correct, inside my cavity. So it will show what is the fluid volume, what is the solid volume, and so on, correct? Okay, now again I will come back to my analysis part, like providing all the boundary conditions. Now you can apply the boundary conditions, like from where my inputs are coming, like inlet, either it can be inlet mass flow, correct, or volume flow, and so on, right? So you can provide flow openings, you can provide your pressure openings, correct? As in this case, I have provided the inlet volume flow of 36 meter cube per hour from this end, correct? And at the other end, I have kept it at environmental pressure. So the setup is pretty easy. And from the list of goals, so these are the things what you want as an output. So you can measure the pressures, you can measure the velocities, you can measure volumetric flow rate, mass flow rate, even temperatures, and so on, correct, as an output. So in this case, I want to measure what is the velocity. So I've created few goals. I want to measure what is the inlet pressure, what is the outlet pressure, correct, and what is the pressure drop. So let me just hide the results. Yes. And what is the pressure drop, that is difference in inlet and outlet, correct? So you can make use of various equation goals also, correct? As in this case, I have made use of this equation goal to represent the pressure drop. And last, my aim is to calculate the CV, correct? So I have made use of the formula of the CV and created an equation. correct? And once everything is done, we put the analysis on run. So in the interest of time, I have already ran the study and I will take you through the results. So this is my pressure plot, correct? So with the help of this post-processing tools, you will be able to know with the help of these vectors the direction of the flow, correct? So not only pressure, if you want to check velocity, correct? So all these things can be plotted here, correct? And finally, I want to check my goals. That is, what is my pressure drop and what is the CV value of this wall. Yes. So what I am getting over here, when my flow is at 36 meter cube per hour and outlet is at environmental pressure, what I am getting, the pressure difference value and the CV value, what has been calculated, correct? I will again jump back to my presentation. Yes. So these are the few post-processing results, right? For this condition, full open condition, I got these are the pressure values. Even you can plot flow trajectories, right? Which will dynamically show you the flow pattern of your fluid. In this case, it is water inside the cavity, how it is behaving, correct? And this is the value of my pressure drop. You can get all the post-processing in the form of charts as well, right? And I have performed one transient analysis, which is time dependent analysis, correct? So I have ran this analysis for the say time of 5 seconds, and for 25% open condition, you can see that the valve is 25% open, and this is my transient study. So you can run it for a specific amount of time as well, correct? So we have both the options, steady state as well as transient analysis. And if I talk about the results now, let me just go back to the model. Yes. Now this is my full condition. You can directly clone your studies. Cloning is a very good and very user-friendly tool in which all the settings what you have given, right, to create the study will be copied to any of the configurations. Correct? Say I want to copy this to quarter open condition, right? I will give the name, for example, new study, and all the settings of my full open condition will be copied to the quarter open condition. So if I just hit OK, yes, we can see the configuration will change automatically and all the setups will be available. You will just have to run it once, correct? So likewise, you can just clone your studies, correct, and run your analysis. So this will not only save your time, correct, if you want to perform the analysis of various configurations, correct, and you will get your results at much faster rates. So the similar results have been calculated. The pressure for full open, 3/4 open, half open and quarter open, and these are the results. And these are the goal plots for each and every configuration. So we can concentrate on the CV right now. So the flow coefficient value for 100% open is 316, right? And as the wall, I am closing the wall, right? The CV value is reducing. For 75% open, it is 269. For 50% open, I got the results to be 134, and for 25% open, I got 57, nearly 58%. Correct? So a good comparative analysis can be done, right, for different configurations of your wall. Now, the equation what I have given in the software for the CV, now this is the same equations, right, what we have used in our colleges, right? The equation of CV is 11.6 with a volumetric flow rate, right? Specific gravity upon pressure drop raised to 0.5. And I did the same theoretically, that is I calculated it mathematically also by inserting all the values. I got the CV value for full open condition of wall to be 318.84, correct? And what SolidWorks Flow Simulation gave me, it was 316.1, correct? Again, the time spent on your hand calculation can be reduced very much, correct? So this will again provide you more time in innovating your product, correct? So the percent difference was nearly 1%, which is nothing we can say. So the same, I did the hand calculation for all the wall opening conditions, correct? And this is a chart what I have created of hand calculation versus the SolidWorks Flow Simulation results. And percentage difference were merely 1%. Correct? So the tedious work of hand calculation can be reduced, right? It can be eliminated. We can directly take advantages of the software and check the results and come to the conclusion, correct, that this design is the best design or any changes are required to be made or not. Now let me move ahead to the next problem that face most of the wall industries, is the problem of cavitation. Now the cavitation occurs when there is a change in the pressure and it occurs at a very fast rate, correct? So because of the change in the pressure, if there is a very small opening, correct, so there is drastic change in the area, and because of that the cavitation occurs, which will affect the internal part of your wall. It may erode it, right? Now we have the option of cavitation inside the software, which we just have to tick. Now let me just take this example and show you how you can check whether any cavitation is occurring inside your part or not. Yes. Okay. Now this is a simple cone wall what I have created in the SolidWorks. So it just consists pipe and this center there is a cone. Now if I take a section from the top, you can check. I will just change the transparency. Yeah. So you can check that it is not fully opened, correct? There is a small opening what I have provided here. Okay. I will just change the transparency again back, correct? And one of the best advantages of SolidWorks that it is within the single window, you can go to your models, do the modeling change, again come back to your analysis and run for the results, correct? So there is no need to switch on from one CAD software to another analysis software. So it gives the power of analysis even to the CAD designers, correct? So even the CAD designers can perform the high level of analysis, right, inside the same tool. As in this case, I have provided the inlet velocity, correct, and there is a pressure at the outlet. As I have mentioned that in your wizard you can just check mark the option of cavitation if you are interested to check the results of cavitation, and my goal is to check the density of the fluid. correct? And once I run the analysis, I will just check my results. So we can see here that there is drastic change in the density of fluid, correct? Now we have the option of probe, where you can just probe your results, correct? So it will make you understand what are the results at various regions of the cut plot. We can see there is a drastic change in the density in this small region, which has affected in the cavitation issue, correct? So you can leverage this kind of problem, this kind of solutions also. I will just hide them, correct? So these are the results. So the density of the fluid at this specific area has been changing drastically, which has resulted, or which could result in the problem of cavitation, which you can understand pre-hand, correct? Before even you manufacture the product and do the testing on it. So you can just go back to your designing team, makes few changes, right, if required, and then run the analysis to check the results again. Now moving ahead, as we come to the last topic of today's webinar, that is what if analysis. Now what if analysis allows for multiple design variations to be tested quickly and accurately. As the name suggests, what if means, what if I change the diameter of the wall, right? What if I change the inlet pressure or inlet conditions of the wall, right? If I change the inlet conditions, say for example from 20 to 30, 30 to 40, 50 and different values, how it will affect my wall, correct? If I change the diameter of my wall. So multiple designs or multiple combination of conditions can be run in the analysis. Now this is an example of a piston wall, right? So the water enters and moves actually towards the piston from one end, correct? So pressure is built on the piston and the water can then move radially out through the exit holes, correct? There are these exit holes over here. So the task is, so we need to carry out the analysis of multiple configuration of the assembly. What if I change the location of piston, correct? What if I change the pressure of inlet, how it will affect my wall, right? So likewise, multiple configuration of assemblies can be run. And these are the conditions. My inlet is 2 bar and outlet is 1 bar. Now let me jump on in my SolidWorks. Yes. So this is a simple piston wall. Again, it is made up of various parts that I have just assembled them together. I will just take the section. Yes. So this is the piston which moves to and forth, and radially there are 4 openings. You can see over here. These are the 4 openings from where the fluid escapes, right? Yes. So this is my inlet, what I have applied in this region, and outlet is applied at these 4 circular holes which are placed radially. So the pressure will be coming on this piston, right? So I want to check what is the static pressure coming, correct? Also I want to check what is the force coming on this region what I have selected of the piston. What is the force? So you can select the direction, as in this case I want to check what is the force in X direction which will be coming on this faces of the piston, right? Yes. So since this is a symmetry model, correct? It is a circular symmetry. So what I have done, I have run this analysis only at the 1/4 region, correct? So since it is a symmetry, so the same results can be created here. So you have the option to choose your computational domain also, correct? As in this case, I have chosen 1/4 area only because of the symmetricity, correct? So these are the results of my pressure. Similarly, you can make use of various post-processing result options which are available, correct? So we have even option of acoustic power if you are interested to check what is the noise coming inside your model, right? In terms of decimal, that thing can also be checked. If you want to check turbulence, yes, we have the option. If you want to check turbulence also, correct? So these are the few results which you can make use. And finally, I want to check what are the force which is coming on this piston, right? So I am getting the force to be around 2 Newton on this piston face, correct? Now moving ahead, I have created this what if analysis, correct? Now what this does, you can provide your input variables. Like in this case, I want to change the location of my piston. I want to move it back or forth in x-axis, correct? So you can specify the value, correct? I want it to be 0.003 to 0.006, correct? So this is created. I even want to change my inlet pressure from 1.3 bar to 2 bar, right? So we have the option, you can provide the values by range with number, range with step, right? If you provide it 2 bar here, 10 bar here with the step of 2 bar, so it will make 2, 4, 6, 8, 10. So 5 number of studies will be created. So all these things can be done here. Finally, I want to check the output parameter. That is, I want to check what is the force coming on the piston. And likewise, it will create the scenarios. Software has created 12 design points. That is nothing but the permutation and combination of my input variables, correct? This is 4 into 3, 12. So no need to run this 12 studies individually, correct? So in one stretch, it will run these studies, and finally once you complete the analysis, all the results will be provided to you here. With the combination of piston location 0.003 and inlet pressure of 1.3, the force which I am getting on my piston face is 0.1 Newton, and likewise all the results will be displayed for you here, right? Now this is a very good tool if you want to optimize your model or optimize your valve, correct? So at one stretch you will get a number of results from which you can understand and create the necessary changes if required. Now coming to the conclusion parts, right? As I have been saying, it is a single window integration with SolidWorks CAD tool, and it has automatic associativity with SolidWorks geometry, correct? So if you change your geometry, right, and you come back to your analysis, you will just have to run it once. There is a good associativity between your CAD as well as simulation, correct? No need to again set up everything from scratch. Then as I have shown, automatic fluid region can be detected, correct? Your fluid domain can be automatically detected, which will make you understand that where my fluid will be flowing inside the cavity. Again, user friendly, and it has a very short learning curve. Now if I talk about other analysis that can be done apart from the wall analysis what we have seen today, you can even perform heat transfer, right? If there are rotating components like impellers, right, so that thing can also be done. Now we have good acoustic analysis inside the flow simulation. Even you can perform electrical CAD interchange, right? Electrical and mechanical CAD interchange is available, and you can perform the flow simulation on your electrical components as well. Then we have dedicated tool for electronic cooling for electronic industries, where the heat generation, right, you want to understand which areas are generating more heat from the electrical component, right, PCB, generator, and two resistor components, and so on. And third, we have dedicated database or dedicated tool for HVAC, that is heating, ventilation and air conditioning, right, for the comfort parameters of the room, where should be the proper mounting of AC and so on, correct? So this is the capabilities of computational fluid dynamics in general. So besides CFD, again we have the structural analysis, right, where you can perform the structural analysis of your component, right, starting from simple static analysis to thermal, frequency, buckling, and even vibration and shock analysis as well. So this is an entire simulation portfolio what I am showcasing you. Then there is a different suite for plastic ejection mold, correct? So if you have components which are manufactured using ejection molding, right, so for that also there is a different suite of ejection mold, in which you can do multiple cavity analysis, single cavity analysis, cooling analysis, and so on. So if I talk about the few region of applications where the CFD part is used, right, in aerospace and defense, mostly external type of analysis are done, right? In automotive, yes, again it is widely used to calculate the drag force, right, wind loads coming on the component, and so on. A good example of HVAC, heating, ventilation, air conditioning, is the comfort parameter inside the bus or inside the aeroplane, and so on. In consumer goods, again there are various applications where CFD is used, right, and energy, power and process sectors, right. So today we have seen with respect to the valves how you can leverage the flow simulation, but again same goes for pumps, solar panels, wind turbines, tidal turbines, etc. So I'd like to conclude my presentation as SolidWorks simulation is accurate calculator of product design health, correct, with this quote. So if you have any queries, you can reach out to us at our website www.enggtechnique.com, or you can call on the number, or you can drop us an email to marketing@enggtechnique.com. And if there are any queries, I would glad to answer. You can type it in the chat window if you have any queries. So if there are any queries, you can type it in the chat window, or else you can anytime reach out to us, call on the number, or drop us an email. So let's wait for a minute or 5 minutes. If you have any queries, you can type it in the chat window. And for your future reference, we would be glad to associate with you to implement this product in your company. You can reach out to us as well. how it's different from wheel. I cannot understand what is wheel, V-E-E-L. Can you elaborate?
Sir, it's actually Creo in
Okay.
point of view modeling.
Okay.
How how it's differ from Creo in modeling. That's
Okay.
all SolidWorks is.
Okay. So I understand right now you are Creo user, correct? In your company?
Yes, sir.
Yeah. Now
Not in
SolidWorks.
my company.
Huh?
In practice, sir.
Okay. Okay. Thank you. Okay. Now if I talk about the SolidWorks, right? Now again, if I compare it with the Creo, correct? SolidWorks comes in with
Yes, yes.
SolidWorks comes in with part assembly and drawing, correct? And it has full associativity within each other, correct? So there are,
Yes, sir.
if there are any revisions coming inside your model, correct? Once the drawing
Mm-hmm.
is released, correct? So
Yeah.
any edit that you do inside your 2D drawing modeling also, that can be reflected in your CAD model. There is no need to again change your 3D CAD model. Even it is
Yeah.
automatically reflected to your assembly. So one thing is, it is associated within all the modules, part assembly drawing. There is a good relation, and you can see it is very much user friendly if I talk about, correct? And within the
Yes.
single window, if you want to perform any add-on products like analysis or flow simulation, as I mentioned, if you want to perform plastics, so everything can be done within a single window tool.
Yes. Okay. Sir, one more question I have.
Yes.
Uh, uh, in a previous slide, you have done analysis and
Hmm.
various 12 conditions are shown there.
Mm-hmm.
Is it showable at ANSYS also?
Can you just highlight me which condition you're talking?
There is a condition between opening percentage of opening of
Yes.
valve.
This one, uh,
Yeah, yeah,
these conditions.
yeah, sir. There is a percentage where is 30% open, where is 10% open valve
Yes.
condition, and
Yes.
analysis have done in the 12 conditions result for that.
Yes.
Is it possible in ANSYS?
Again, in ANSYS also there are various, I can say, portfolios, correct?
Mm-hmm.
Right. So it is possible in ANSYS, but you will have to choose which portfolio you want to make use of, correct?
Yes, sir.
Yeah.
Okay, sir. Thank you.
Can I answer something? Add something? Gaurav.
Yes. Yes, please.
Ashutosh, for that, sir, you have to do the design, and you have to convert that into the step file, and after that you have to
Mm-hmm.
import the step file into the ANSYS, and after that you
Yeah,
have
yeah,
to run that thing. Okay, but in
yeah.
this condition, what happened? You have to just redesign that thing, just refresh that thing, and continue in the
In a second
analysis.
module of okay,
Huh.
okay,
So you can do the things earlier compared to the ANSYS thing. So
okay.
Yeah, the modeling part you
huh.
cannot do in ANSYS, but as I mentioned
Yeah,
from
yeah.
the beginning, the CAD modeling and analysis part are integrated, correct? So you
Yes,
can
sir.
just switch your tabs, you can do your modeling part, again come back to the analysis part. So this is the major difference, right?
Understood, understood, sir.
Yes, so there is no need to have different tools for CAD modeling, analysis, and so on.
Yes.
You can just
Thank
open
you.
your part from here, do your
Mm-hmm.
modeling changes if required, save it, come back to your analysis, and you will just have to run it.
Okay.
Because whenever
Understood.
you open your step file or STL file, there is always few chance of data loss, correct?
Yeah, yeah,
Because you are converting
yeah.
your file from one format to another. So those data losses are totally eradicated inside the SolidWorks.
There is chance for corrupt files.
Yes, so that is totally eradicated here.
Yes, sir. Understood.
Okay, I want to check inlet and outlet pressure. Yeah, if you want to check the inlet and outlet pressures, correct. So you can just plot the goals here, right? I will just hide the result. Like over here, you can select the goal. Like I want to select this face and I want to check what is the inlet pressure, correct? So I will select the pressure for this, right? And similarly, I will select one more goal for my outlet, select the specific face, right? And select from the list of parameter what you want to check, for example pressure. And once you run your analysis, correct, you will get the results. What is the pressure at inlet, what is the pressure at outlet. So you will just have to define the goals here, and after running you will get the results. Okay, I hope I have answered the query. So I'll wait for another few minutes if there are any queries.
Sir, in answers, there is a various kind of meshes are there. For if I go the analysis of knuckle joint or welded like that. Same thing. I want to analyze in SolidWorks. Then there is a option for various kind of meshes provided in that.
Yeah, so are you talking about structural analysis over here?
No, sir. Actually, no, not structural. It's mechanical. There, like design of knuckle joint or design of a shaft or bearing, like likewise.
Yeah, you if you talk about the meshing, we have the option.
Yes,
yeah, you can perform it with tetrahedral mesh, right? Even we have included hex elements, we have included the different types of elements are available inside the software, right? Even if you want to perform it with beam elements, 1D elements, if you want to perform with 2D elements, shell elements, that thing can be done. And if I talk about 3D elements, then there is tet element is available. Also there is hex element. So these all elements are available.
Okay.
Yeah.
Thank you.
Yeah. Welcome. So you can just type your queries. If you want to speak, you can just unmute yourself and talk, or else you can type in your queries. So I'll wait for another minute. Okay, so as in interest of time, we have started our webinar at 3 and it's 4 p.m. So let me conclude the webinar. I thanks everybody for joining the webinar in time, and I hope you understood all the things what I projected today with respect to the valve industries, correct? And in future, stay tuned for our next webinars where we would project for another industry specific tools, correct? Thank you. And in future you can contact us, right? So if you want to have in-depth demonstration of the software, you can contact us or visit our website or mail us so that we can arrange for the same also. Thank you.